Unit 3, Lesson 9, deals with the special cases that occur while solving equations in general, but specifically what we're going to be working on is when we have variables on both sides. Notice our objective today, different than what it's been in the past few lessons. All right, we want to be able to identify that a problem is a special case and then correctly determine the answer. Okay, so it's a little bit different. All right, special case. That is what we use to refer to an equation that when you go to solve it, the variables cancel out and there is no variable left to solve for. Okay? When we solve an equation, we are solving for the value of a variable, an unknown number. Okay? If there is no variable, there is nothing we could solve. Alright? So, our steps of solving is still the same. We're asked to simplify first, as always. Alright? But now something can happen when you're doing this. Alright? If the variables drop out, then you're left to determine if what you have is true or false. If the resulting equation is true, your answer is going to be all real numbers, which means every single number can work. If your answer is false, that means there's nothing that will work. Okay? Same steps as before, so let's go ahead and get started on our 6 examples that we have today. Alright, example 1. Like we saw yesterday, we know the distributive property comes first. So I have 4x squared minus 8. On this side, I have 4x. Okay? Now, we like to say move the smaller one to the larger one. When we look at these two variables, they're the same size. That right there tells you this is going to be a special case. And what happens is, because these are on opposite sides, I'm going to use opposite sign to solve. Sorry, that should have been red. I want to keep consistent. Alright. Over here I get 0. Over here these cancel, and I still have a negative 8. You'll notice I don't have a variable anymore. When this happens, we go back to this statement up here and ask ourselves a simple question. Is this true or false? Alright, so does 0 equal negative 8? Of course not. That's false. So we would say that there is no solution to this problem. That is the answer to the problem. No solution. In other words, you cannot find a number that will make these two sides equal. Alright, let's try that again. So, once again, I take a look at my problem. On the left I have parentheses, on the right I don't. So, I'm going to take care of my distributive property. Remember, that is a negative 1, so I have negative x, and a negative times a negative is positive 2. And again, I have variables on both sides, so I'm going to move the smaller to the larger. And once again, I have a problem because they're the same size. So let's say we add x here and add x here. Remember, whatever you do to one side of an equation, you do the same thing to the other. Negative x and positive x is 0. And so is it over here. So I end up with 2 equals 2. Alright. Now, once again, we'll notice that there is no variable left in this problem. The variables have dropped out. Alright, that's what we mean by dropping out. They're gone. So, does 2 equal 2? Yes, it does. So this answer is infinitely many solutions, or we'll just say all real numbers. It's easier to say. All real numbers. Alright, let's take a look at another one. Again, it starts out with the distributive property. So I have negative 24 plus 6x equal to 6x minus 24. Keep in mind, if you think you know how to do this, pause the video, try it on your own, and then watch the explanation and see if you get it right. If you got it right, that's awesome, good for you. If you didn't, make sure you copy down the correct work and try to find your mistake and learn from it. Alright, in this case, move the smaller to the larger. And once again, I have same size, so they both cancel out. I end up with negative 24 equal to negative 24. Is that true? Yes, it is. This is all real numbers. All real numbers. Again, it's infinitely many solutions is another way of saying it. They both mean the same thing. Alright, 3 more to go. Take a look at example 4 here. I'm going to distribute. I end up with 9n minus 3 equals 17 plus 6n. I have variables on both sides. I'm going to move the smaller to larger. Obviously, 6 is smaller than 9. And at this point, you should realize that this is different than the previous 3 examples. In the previous 3 examples, when I went to do smaller to larger, they were the same size. All right, these are different, which means I'm going to get an answer this time. So this is not like the previous problems that were no solution or all real numbers. You'll notice I still have a variable. It's right here. Boom, right there, a variable. With that being the case, I need to solve. All right, so I'm going to do that. I'm going to add 3 to both sides. I end up with 3n equal to 20. Divide by 3, and I get n equals 20 over 3. Remember, we don't want to see decimals. All right, give the fraction equivalent in simplest form, please. All right, moving on. Number 5. So one of the things you're going to notice is you need to be really careful. All right, because sometimes you may have a special case and other times you're not. All right, not everything's a special case. Not everything's normal. All right, you have to know how to read and interpret it. So I distribute my x. 6 times a half. Half of 6 is 3. Very easy. It's at this step, the moving, that I'll know if this is a special case or not. I want to move smaller to larger. And I have a smaller one. Okay, which tells me these are not going to cancel out. I have 2x equal to negative 3. If I still have an x on the board, and I do, boom, right there, then I need to continue working and solving. So I'm going to divide both sides by 2, and I end up with x equaling negative 3 over 2. It's okay to have fractions. Now you may be thinking, well, how do I check an answer with fractions? Use your calculator. Plug the numbers in. All right, your calculator knows how to use it. If you don't know how to use your calculator, ask me in class or come in 1C and we can go over it. Well, let's move on. Distribute, distribute. Here we go. All right, 2/3 times 6. 3 goes into 6 twice. 2 times 2 is 4. That's 4c. 3 goes into 3 once. 1 times 2 is 2. That's 4c plus 2. Over here, negative 2c minus 62. I'm going to move smaller to larger next. And notice there is a smaller variable, which means this will have an answer. This is 6c plus 2 equals negative 62. And again, because the variables did not drop out, I need to solve. That's 64, divide by 6. Divide by 6, and I'm going to have another fraction answer. I'm going to change colors just because I'm going to write my answer over here. I end up with c equaling, let's see, I can take a 2 out of each of these. That'll get me to negative 32 over 3. That's an acceptable answer. It's a fraction in simplest form. This is not an acceptable answer. All right, while it's right, it's not in simplest form. So make sure you have your answer in simplest form. Right here. And again, if you have any questions, make sure you're asking in class. See you tomorrow.